In this session, I'm going to look at the advanced table calculations that we can do using Tableau. Now that we know creating the table calculations using quick table, when we talk about advanced, it's simply about I am not using a quick table calculation option. I am simply writing some kind of a code. I'm doing some kind of formulas, using some kind of formulas that are there. So whenever I'm writing such kind of codes to create a table calculation, I categorize them as advanced table categorization or advanced table calculation. So all the different kinds of calculation functions I could see once I create a new calculated field in Tableau. Within that we have table calculation functions. The table related functions are there in the list of the functions. So the table related ones, if I select, I get different categories of calculation. So simply put, let me take a simple data set. We'll continue with our superstore example. So wherein I would be taking, let's say, category on the rows. So I get 3 categories. And I take the subcategories also as a part of the rows, where I'll get something like this. Now, what I want to look at is, I want to create a few table functions. And here, I would always like to work out, right, once I create a table calculation function, I am breaking it down like this. First, I had a category, and within the category I am doing a subcategories. So the whole breakdown is coming in this kind of a mechanism. So what we'll do is, at every stage or at all the calculations, we will try to compute using the subcategory, which means the category is the partition for us and subcategory is the addressing. Right, when I am saying compute using subcategory, the addressing is happening through subcategory and the category is acting as a partitioning. So that is what we'll do. We'll try out different kinds of table related functions. Now if you say you are creating an from the analysis, you are creating a calculated field. Here using the table calculation we have different kinds of functions. The first, index, last, etc. Right? So they are called as meta table functions. So let's say different kinds of functions I want to define. One, I have meta table functions, for which we have some formulas like first, last, index, size. Some such kind of meta table related functions are there. Then we also have a few which are also called as previous value, and we also have lookup. So different categories of functions, right? So probably I can put this previous value and lookup as the second set of functions. The third set of functions which we talk about are running functions. We'll talk about each one of them. The running functions come out as running average, running count, running sum, running minimum, running maximum, something like this. So we can create those kind of functions. If you see here, you are seeing a lot of running related. Then you have some rank related functions, right? Rank dense, rank dense, rank modified, rank percentile. So a few ranking related functions are there. So different ways to rank based on the aggregated values. And once you have done with the ranking related, then we have script related. So which are more like R. You can use the R script. I'll talk about all of them. So then we have a script related functions which are more and more associated with R script. Then size we have already talked about. Then there is a total related function. I'll come back to that. Then windows related functions are there. Window average, window count, window max, window min, window median. So some window related functions are there. So these are the different categories of functions which you see under the table calculation. What we'll do is we'll try to compute each one of them, at least one example. So under the meta, we are talking about first, last, index and size. So let me create 4 important formulas. Let's say first one, wherein I use a formula called first and I say OK. So I got first one. Similarly, I want to create another calculated field, let's say last one, and I use a formula called last. Okay, I'm saying okay. Then similarly, I am creating one more calculated field called as index 1. I am using the function called index. Okay. Then I am creating one more calculated field called size 1. And I am calling it, I am using the formula size. Now these are the 4 meta table functions. So they give the information regarding the partitioning and addressing. Let's see what gets represented. I drag the first one here. I drag the last one. I drag the index one. And I drag size one. All 4 of them I have dragged here. What I can do is I convert them into a table. Now what I could see, index 1, 2, 3, 4 up to 17. And when we talk about the first, it is talking about the offsetting from the first row in the partition. Now right now the partition, we have not done any kind of a partition. So it is doing the offsetting from the first row for every element of the table. So that's where 0, minus 1, minus 2, minus 3 up to minus 16. The same way last goes from the last row of the partition. Vis-a-vis the last row, how many rows up? 1 row, 2 row, 3 row, 16 rows. Right? And size is talking about the total size of the partition. Now, here we did not do the partition. We have to do the partition. When I have to do the partition, we have already said I can use compute using. When I use compute using subcategory, automatically the partitioning is happening based on the category. So all these numbers should be revised for the categories. Let's look at it. First one. When I say compute using and I select subcategory. Now you could see within each partition, the first row is becoming 0 and below it, it is becoming minus 1, minus 2, minus 3 up to minus 8 here. The same logic if I look at index, I make it using subcategory. Now at within the subcategory, within the category, all the subcategories are indexed. But when it goes to a new category, again the counting is starting from 1. Similarly, the same thing within the technology. Now if we do the last also, the last row in every partition will be a 0 and with respect to that 1, 2, 3s will come for the others. Now the same logic goes even with the size. So the size will be with respect to each partition, not the whole table. So it is saying the size of the first partition is 4, the next is 9, the next is 4. So what you could clearly see is at least the first and index and last, they are affected by the partition and the addressing that we are doing. But the size will give me the same result no matter what is the direction that I am giving. So that is the one set. The other set of formulas which I talked of are the previous value and the lookup value. Right? Let me create again two new fields called as the lookup value and the previous value. Either I can create in the same sheet. Let me create it here itself. Right? I create a calculated value called lookup value 1. I want to look up for the previous value. So I'll simply say lookup the expression. So I'll use something like attribute. Right? I'll take the subcategory of the previous period. So I'll say attribute associated to the subcategory, comma offset -1, which means the one that is above it. So it will take the subcategory that is above it. And I say OK. So LV1 got created, and if required, I'll pull LV1 here. Okay, I want a simple tabular representation. Oh, LV1 is coming out here, so let me put it here. The LV1 why is it coming out different colors? Okay, the LV1 we have simply got the attribute associated to the subcategory of the previous. So let me see what the values it generated. Right, LV1. Oh, it's a text, right? What I can do is LV1. I'm dragging the LV1 here. Alright. So when I pull the LV1 here, okay, it is showing me null, and from here it is showing the previous value. Chairs here, furnishings here, tables here. But again, I want to make this LV1 also, let's say the partition based on the category, which means I want to do a computing using the subcategory only. So I go to this LV1 and I simply say compute using the subcategory. So which means every first entry will become a null still, and for the remaining entries it would refer to the previous value. So I am getting the last, or probably I am using the lookup value just by referencing it to the attribute of the subcategory -1. Similarly, let's say I want the previous value, right? So let's say I want the previous value. So I could create another calculation. I create a calculation saying PV1. So I could clearly talk about the previous value associated with the attribute. So the current attribute itself subcategory, right? I am selecting the subcategory and I am trying to find the previous value associated with that subcategory. Okay, so there is a previous value that got created. So let me see what it contains. So I pulled PV1. Now in this case, it is giving me the bookcases only across, because here there is no previous value, so it pulled out the bookcases. And now from here onwards, the previous value is bookcases, so it is pulling out. So everywhere it is bookcases. But now let's say again, I want to make this previous value compute using the subcategory. So for the first one, it would always be bookcases. The next, it's always appliances. The next, it's always accessory. Because in the first case, there was no previous value, which means the current value itself will be considered. And from the second case onward, the previous value is this one. So that's where you could see the bookcases shown here, the appliances here, accessories here. So that is how I can use the previous value as a function. Then comes the next set, right, where we are looking at running function. So as I said, in running functions, we are talking of running average, running count. So let me create a couple of fields again just for us to understand. So let's say I want to do a running sum 1. So I'll use the formula called running sum, and within this running sum I just need to provide an expression, and this expression should be an aggregate, right, because it has to add the sum of the sales to a running total. So I want to do a sum associated with the sales. So I want to create a running sum, especially with respect to the sales. Alright, let me create OK, and let me drag this RS1. Now instead of this, I can very well convert it into a table. I got my RS1, right? LV1 actually I don't need it as a part of the color. So I got my RS1 114. After that we went adding it up, 443, right? Then it's again added up. So there is a kind of a running sum. Probably for understanding it, let me pull the sales also here so that you can understand it much better. So the sales, if you see, it is 114, then it is 328, 91, 206. So 114, these two added together making it 443. Again another 91 added made it 535, and so on. But again here also I want to segregate it, right? The sales also, whatever the running total, that running sum that I have got, RS1. This running sum also I'll compute using subcategory, which means I'll get the running totals for each subcategory. So the furniture, the sales is around 742. For office supplies, it's around 719. And for technology, it's around 836. The same way, probably I can very well go with another running kind of a function. Let's say I want to do running minimum, R min 1. So I'll again use running minimum kind of a formula. Again I could use the sum of sales only, right? When I'm saying running minimum, the sum of sales, and I drag this running minimum also into the category, I could see that, okay, here it is 114, 114, but the next one came, 91 was the minimum, so it's showing the minimum of 91. Whereas here also 3024 is the minimum, which it is showing 3024. But now you could see that even here it is 3024 because it is taking the table as the scope. Now I can very well edit it and I say use subcategory. Now the minimum is coming corresponding to each of the subcategories. So that's where we can use the running related function. So the running sum is actually adding the sum of the sales to a running total. So for every row in the partition. Similarly, in case of running min, it is keeping the value of the sum of the sales if it is the smallest value. So until it is encountering a value which is smaller than that, that is being retained, and the moment it has got a value smaller than that, the newer value is being displayed. So that is what is happening to the running sum kind of functions. And then we have a few windows related functions. So these are the functions, they operate across all the rows in the partition at once. So they are basically aggregating all the aggregates. Right? You have to understand when you have to use each of these. It is aggregating all the aggregates. What does that mean? All the value in a particular aggregate, in a particular partition, will have the same value. Like the same, instead of running sum, let's say I want to create a Windows sum. I'll call Windows sum 1. right? I'll create W sum 1, which is Windows sum. So let me take Windows sum, window underscore sum, and the input I still give the sum of sales. But the difference what we see here between this and running sum. Alright, let's look at it. Windows sum 1, if I have pulled it here, all I could see is for all of them, here it is showing 2297. Whereas if I do this Windows sum, right, if I typically do this Windows sum across the compute using the subcategory, for each subcategory the value will be the same, right? That the last value that comes in a running sum, that would be the value across all the aggregates in case of the Windows function. So we can, when required, we can use even this Windows related functions. You can use Windows sum, Windows min, Windows max, Windows average. A lot of these kind of Windows specific functions are there. Now we have different formulas that are related to the rank. So probably I can very well go into a calculated field called rank 1, where I am using the formula, let's say a simple rank. Right, I can talk about again an expression. So here I could very well take rank based on the sum of sales. Right, I'll still say rank based on the sum of sales. I say okay, and when I'm pulling the rank 1 into this category, all I could see is okay, 1 to 17 ranks are generated here, but again the same logic, I can very well do it within a partition. So go to a subcategory, I get okay 1, 2, 3, 4 here, I get 1 to 9 here, I get 1, 2, 3, 4 here, depending on the values that are typically coming up. Right, based on the sales, I can talk about what are the ranks associated. By default, it's a descending order of the ranks that are coming up. The same way you can really play around with the R script functions, especially when you are allowing integration with R. Right now I'm not going to take them up. Then similarly the total function, whatever is there, it is working. It is actually requiring the underlying source for all the source data rows that make up a given partition. So slightly different function. In some cases, it will yield the same function as same value like the Windows function, and in some cases it differs. But the more you try to explore it, the more you get the differences associated with it. So these are the different kinds of formulas or functions that are there, right? And we really need to get some basic hold on the Windows related or the table related calculations which we generally do, so that we can advance to a much quicker level and a much faster level. Now let us say I want to do some kind of computations. Let's say I want to look at some day wise related stuff. So here, okay, let me pull things into a new sheet. So I want to look at some date related stuff. How many orders have happened on a particular date? Right, so day wise or something, I really want to see how many orders have really come out. So I am pulling the day into the column. So by default it is giving me year. I am not interested in the year. Let's say I am more interested in the day. Right, I am more interested in the day. Okay, now it is telling me with a kind of a bar chart that Gantt chart right from the each of the days, 1st July, 1st November, 1st March. It is showing me the kind of days that are associated with each of the days. Now I really want to find out corresponding to each of the days probably how many records are there. Right, let me see how many records have come up. Now suddenly the chart got changed into a line chart. So these are the number of records that have come day wise. So there could be so many ups, downs, lot of spurs in the data. Now, right, this is more a regular pattern that is there in my data. So it's a time series data. So some ups and downs are very much clearly seen. So I want to really smoothen out some of the stuff, because sometimes it could be very much distracting when I am more interested in looking at the overall pattern. So this is where I really want one more representation of the same. So the same total number of visits or the total number of records, I will create one more version of this. So I get one here, one here. But the second one, I'll create it as a moving average. Instead of just taking a plain number, the second one I'll take it as a moving average. So how do I do that? I go here, right? I do a quick table calculation. I go into moving average. Probably this is slightly better. There is a lot of smoothing out that has actually occurred. Now I really want to know what is the period for which I have done this smoothing. Right? So this is a moving average of the number of records from the previous 2 to the next 0. Right? This is how it has computed from the previous 2 to the next 0 along the table. And that is what is the computation which it has used by default. Now what I can very well do, so I am looking at the number of records, right, using the moving average, quick table calculation, I have smoothed out. And now I have to edit some of the stuff. So I go here, I say edit. Right, now that I have shown moving average, I am taking the edit. Okay, it's a type moving calculation, previous 2 values. No, I'm not interested in the previous 2 values. Let's say I want to put previous 10 values. Right, so the last 10 days I'm smoothing out. Okay, or probably the week, if I want to smoothen out, I'll say last 7 days. I'm smoothing out the last 7 days and moving across the table. So that should be sufficient. I say apply. Now I am getting a much better smoothened version. My sales are typically going up. Right, there is some kind of an uppish trend that I am seeing in my sales the moment I am able to smoothen up my data. Now this is showing a much better picture rather than this, which is more and more distorted. So the table calculations really help us in trying to identify the bigger patterns in your data by bringing this kind of moving averages as a part of your data representation. Then, okay, let me go back to this, or if possible, let me duplicate this sheet so that I can do something more better here. So we'll work on some other sheets. So the sheet 1, let me call them as the table functions, right? Different table functions is what we have discussed there. In sheet 2, let me rename it as moving average. Then sheet 3. So I want to really work out a little bit differently on this. So once we work out, then we'll try to rename the stuff. So for time being, let me pull out everything. Right, I'm just keeping the very basic stuff. Right, we have the category, we have the subcategory. Right, or this time let me not look at the subcategory. This time let me look at the region. We'll do something else. So I'm taking the department, I'm taking the region, I'm simply looking at the sales. Very simple stuff. Right, measure name, measure values I'm pulling out. So I'm simply taking the region, the category. Within the category I'm taking the region, I'm taking the sales. Now let's say I want to sort it. Right, I have the category, I have the region, now I want to sort the data. Descending order of the sales. Let me try this. When I sorted it, you look at it here, west came up, right? West is 1, east is 2, central is 3, south is 4. But you look at across, it's same west, east, central, south. But okay, the first two are fine, the order is maintained, but what about the third? In technology, the west is lesser, but still it is showing at the top. The east is higher, but it is still showing in the second. So what has actually come up is overall the west is first. So there is an overall ordering that is coming out. In the default case, what is coming out is the overall ordering. So in the overall sales, west is the highest, then comes the east, then is central, then is south. But it is not specific to each of the partition. Right? It is not specific to each of the products. So the best is always in the top. But it is highest in the overall sales, but not in each department. You could very well see in the technology department, it is coming second, but still it is shown at the top. So this is where I wanted to see at slightly different sort order. Each department, each category, I really wanted a different sort order. Right? Now this is where I can rely on a calculated field called rank. So what do I do here? How do I work it out? I go here, I create a calculated field called, right, or probably we have the rank. So let me see if we can use that rank. We have already created this field called rank. And now, whatever the rank that we have created, I don't want, this is coming out as a number. First of all, let me convert it into a dimension. Right, this is a number. So I am converting it into discrete. So the rank 1, probably I can drag it into dimension first of all. No, because it's a calculated value, the rank 1 is coming out here. So let me drag this rank 1 first of all, let's say in between these two. Right? So this is the rank 1 that is coming out. So first it's the category, then it's the rank, then it's the region. But now you could see the rank is actually, it is showing 1 to 12, but I want that ranking actually coming out specific to each region. So I want a separate ranking for each region. So it's coming out 1, 2, 3, 4, west, east, central, south, west, east, central, south, east, west, central, south. So because I have brought in the ranking out here, now I could see there is a different categorization that has overall come out. And right, so we are typically showing the category first, then the rank, then the region. Right, and now when we are typically doing the ranking, probably category wise, we have got probably the region wise, we got 1, 2, 3, 4 for each of the categories. And if required, even the same ranking, I can very well show right? This particular field I can simply hide it. Oh, sorry, this one. Okay, so this is the ranking. So what I can very well do is I can't hide this header. Right, so which means the rank from here, let me try pulling this rank onto the labels. Okay, so from here, let me try pulling the rank onto the label. So I'm getting 1, 2, 3, 4, 1, 2, 3, 4, 2, 1, 3, 4, right? So now that I have the labels here, one thing is I can, so I need it in the ascending order. Or in the descending order. I really want that. Okay, let me put this here. So I can very well hide if I am putting this rank here. Okay, so it is coming east, west, central, south. So the ranking is, this is coming in a ranked order. But what I really want is I want just the headings that are shown here, but I don't want something to be shown here. So let me do the sorting. Let me do the sorting based on the rank, and let's say okay, so let's say this is the rank that I'm getting. So I'm putting up the headings out here, and if required I can even hide these headings also. So I'll drop down field on the rank, and I can very well stop the show header. The moment I have taken out this header, all I am seeing is 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 here. Now this is a sorting that is happening purely based on, right, without showing the rank here. I am still showing category and the region, and the ordering is purely happening based on the sales for each of the region. So this is one more, so it's a kind of a dynamic ranking or something that I can call, right? It is purely a ranking based on the levels within partition, ranking within partitions. That is what we are trying to do here. All right. Now comes the other important aspect. Let's say I am interested in a process called late filtering. Another important aspect I want to talk about is the late filtering. Okay, so let me consider the same stuff, right? Probably I am not interested just to quickly look at. I am interested only in a category and the sales. For time being, let me take out the region. So very simple stuff, category and the sales. So we have built a simple such kind of data, or let me do it in another one. Let me go back, right? Everything remaining like this. Let me duplicate this sheet, and in this let me call it the late filter, right? I'll call it late filtering. Here I'm not considering anything else. I'm just taking out everything, looking at category and the sales. Very simple stuff, right? And in this view, I am able to look at percentage of the total sales for each category. So let me create, so here I am looking at percentage of the total, right? Percentage of the total sales. And what I can simply do is I can drag this onto the label as well. So I get 32.3, 31.3, 36.39. And now let's say I want to drag the category, right? I want to drag the category into the filter and I want to remove let's say the office supplies. I want to keep only the furniture and the technology. And when I say apply, what comes out is this is updated. The percentage is showing 47 here, 52 here, which means whatever are the ones that are displayed, the percentages are updated with respect to the ones that are shown in the view. Now this is a very important aspect for me to look at. So initially when I have included everything as a part of the category, right, so when I included even the office supplies, these are the percentages. And right now we are using it as a filter and I have simply removed the office supplies as a part of my list. Now, because the table calculations are performed after the aggregate data is returned. So here our aggregate data has come out already. And on that values that have come out, the table calculation is getting performed. So the filter that we have applied on the department has already been evaluated at the data source. So the aggregated rows, they really don't include any of the categories that are excluded by the filter. So here they are not including any of the categories that are excluded by the filter, which means the total always comes to 100%. But if I want to still show these two, but I want to show that these two form only 70% of the total. I don't want them to show 100%. So this is where we are calling as late filtering. Because in a regular filtering, first of all the data comes from the data source and before it is formatted, the table related calculation are applied. So when we are talking about the filter here, when it is going for fetching the data itself, it is fetching only these two categories. And because it has fetched only these two categories, the summation is coming out to 100. But what I want is I want all of them to be fetched. And while rendering, they should show only 36, they should show 30 or 31, 32, whatever it is. So because while it is bringing, it should bring all three. But while rendering, it should render only for two of them. Right? So I wanted to see the percentage of the total sales for all the departments, even if I don't want to include them as a part of the display here. This is where we are calling it as a late filtering, and that is possible only if the table related calculation is used as a filter rather than a simple category as a filter. I look at the table related calculation as a filter. Now for that I create a simple calculated field, a table related calculation called category 1. Let me create a category 1, which is what is an indication of a late filter. So here I will do a lookup of the attribute associated with the category. So I am looking up the current value of the attribute associated with the category. So this particular field, which I have created as a lookup. Now the category I am taking out, this particular lookup, which I have called it as a category 1, this I'll put as a part of the filter. And here I'll include only these two of them. Now you see the difference. When I have included these two of them, I'm seeing 32.3 here, 36.39 here, which is a clear indication that while fetching, all the values are fetched, but while displaying, I'm displaying only a portion of them, right? So instead of keeping the category as a dimension, I have kept the the lookup, which is the window related, or which is the table related function associated with that particular attribute. That is what I have kept in the filter category. So the filter is not applied at the source. At the source, till the whole data is coming, the aggregate data is visible to other table calculations, and this table calculation has merely hidden that particular category, which is what is not being shown as a part of your final view. So that's another interesting way of handling the late filtering kind of stuff, which is another important aspect of the table calculation application. Then Then the other aspect, which really we can look at many such kind of aspects. You can think of many such kind of examples where we may be more and more interested in performing the table calculations, and which can signify the importance of different kinds of table calculations as a part of our data visualization exercise. All right. So very important set of functions, formulas, applications, which we all need to be very much comfortable with. All right. So thanks a lot for listening to this session. Thank you very much.